Hello, grade 9s. We are starting our new unit called geometry. And in this unit, we're going to be talking about a whole bunch of different types of things within geometry. We're going to be talking about circles. We're going to be talking about angles. And we're going to be talking about lines. Now, as we go through this unit, there's actually quite a bit of new terminology, as well as quite a bit of new notation that we're going to be talking about. So as we go through, please note what that notation looks like so that when we answer the questions throughout the unit, we can always make sure we're doing so using that appropriate notation. We're going to start off by introducing points, angles, and angle relationships. So to start off, a point is something that we use to mark a location or a specific spot. When we note what a point looks like, we usually use a dot to indicate what point we're talking about. And then we use a capital letter to represent that point. So we always use capital letters. We do not use lowercase. Now, sometimes a point can be located where a corner is created. Now, a corner in math is called a vertex. It's the point in which exists exactly at that corner. So if I look at the diagram, I see I have this, what looks like a straight line with an arrow on it, and another straight line with an arrow going on it, but they meet at the very specific point A. So we can say the point A is also a vertex. Now the plural of vertex, in case we're ever talking about more than one, is vertices. Okay, so you got some general notation there. Now let's talk about angles, because we can use or denote angles using the points that create them. So angles can typically be named in two ways. The first way is by what the vertex point is called. So here, if I'm taking a look at my angle, I'm looking and I'm going, okay, I'm starting from A, I hit B, which is my vertex, and go towards C. Or I could think of it backwards. I start at C, go towards my vertex B, and hit up A. I kind of think about if I never lift my pen or pencil off the paper, what kind of order of the points I'm hitting is. Now, here I know my vertex is B. So one way I can name it is angle B. Now, this symbol here, it's kind of like a capital L, but it's been squished a little bit more. The bottom is still exactly flat, and then it's just been angled upwards, is the angle symbol. Now, this is really different than a capital L, okay? We've got a different shape here. And it is also a little bit different than a less than symbol. A less than symbol you might have seen before in previous grades. We use it to indicate like numbers and their relationships to each other. So 1 is less than 2. But the angle is unique in that the bottom is flat and then it opens upwards along the diagonal. Now, sometimes we choose to not name angles by just their vertex because it might be a little bit confusing. We might not know what angle I'm talking about, especially if I have more than one angle with the same vertex. So I've just altered the diagram here to now have 2 angles, actually 3 angles. This original one, this new one, but also I can talk about this guy here, and all of them have a vertex of B. Now that could be really confusing, because if I just say angle B, you might not know which one I'm talking about. So we introduce a new naming system, and that new naming system involves 3 points. And before I was talking about if I wanted to trace that angle, I'd start with my pen at one point, and I'd trace, I'd never lift it up, and I can redraw that angle. Well, the order in which that name occurs is the same order in which points I hit when I do that. So I hit A first, then I hit B, then I hit C. The key thing being the vertex B was in the middle. And you might say, but Miss T, what if I started at C and traced and went C, then to B, then to A? Well, I'd say, great, that also works. So when I name angles, typically I can name them by 3 points to really avoid any confusion. The order that I name them doesn't quite matter, but that middle letter always has to be the vertex. So if B is the vertex, B always needs to be in the middle. Okay, now let's talk about types of angles. Now, these types of angles, I'm sure you've seen before or heard of before, but let's take a look. So an acute angle is an angle that measures anywhere between 0 and 90 degrees. So it could be 0.1, it can be 89.9, but it could be any number in the middle as well. A right angle measures exactly 90 degrees. And to show that an angle is a right angle, we typically use this little small square in the corner or the vertex of that angle to show that it is exactly 90 degrees. An obtuse angle is one that measures between 90 and 180. So that could be anything from 90.1 to 179.99999, but that's what makes it obtuse. Now, these three angle types I'm sure you've heard of before, but there are also three additional angle types. The first one is a straight angle. Now, a straight angle honestly looks very much like a straight line, which is where straight angle got its name from. That straight angle measures exactly 180 degrees. So it's like putting two 90-degree angles together and only going across the exact bottom. The next one is a reflex angle. Now, a reflex angle measures anywhere between 180 and 360. So that means I'm going beyond the measure of a straight angle, but I haven't made a full circle yet. So I can be 180.1, I can be 276, I can be 212, I can be 358. Anywhere between and not including 180 or 360. A full rotation is that last angle, and that means from wherever I started, so I started here at point R, I'm going all the way around back to point R. So I'm going R to N to R. Now this full rotation measures exactly 360 degrees. And if you'll notice in my diagram, that angle kind of looks like I've created a circle, which kind of makes sense because a circle measures exactly 360 degrees. Now, something I'll point out while we're talking about angles and their measures. So we measure angles in degrees, and that little tiny circle, it almost looks like an exponent, but it isn't. It is a circle in the top right corner of the number is my units. Now, it's actually really, really, really important that we always involve units every single time we write an angle. Why? Well, technically, in grade 12, you'll learn that there's another way to measure angles. Kind of like we have different ways to measure distance. We can measure it in meters, we can measure it in kilometers, we can measure it in centimeters. There's different units depending on what we're doing. Well, in angle measurements, there's actually different angle measurements as well. Degrees is probably the most common one. But as you get older, you'll learn that there's also a unit measure called radians. And the reason why it's so important that that degree symbol's there all the time is because technically, if there is no symbol, then we assume it's radians. And radians are way different in terms of what number value they have. 360 radians is going to look very, very different than 360 degrees. Kind of like 360 kilometers is way longer than 360 centimeters. So we always want to make sure that every single angle has that degree symbol on it all of the time. Okay, so first things first, we are going to take a look at each of these angles, whether they be in degrees, the measurement, or the types here, and we are going to go ahead and measure them and try and identify them. And when we take a look, I'm going to throw in some curves here so that we know which side of the angle that we're talking about. So here we go. We're going to follow these, and we're going to try and identify them all. Can you take a moment and try and identify them yourself? Pause the video. Okay, welcome back. So when I take a look at this, I'm going through, I'm saying 49 degrees. Well, that's between 0 and 90, which makes it acute. 360, well, that's the last one we talked about. That one's a full rotation. 288, I could always backtrack and look. Well, 288 is between 180 and 360. So 288 would be an example of a reflex angle. 181, oh, that one's also between 180 and 360. That would also be a reflex angle. Now, when I take a look here, the way that I kind of imagine things or picture things is I like to picture one line, and then I want to see, does it go past a straight line? So if I extend that, does it go past? In this case, I do not get towards that straight line. I can also, come back. I can also kind of draw in that 90 degrees from my line that I originally extended, and go, okay, oh, it's beyond 90 degrees. So that one must be obtuse. And I could do the same thing, same process. So I'm choosing one line, I'm choosing this one, and I'm extending it, and okay, I'm definitely not at 180. That would be a straight angle. And if I drew in that 90 degree, I can see I'm not quite at 90 degrees yet, so this one will be acute. Here I have a straight angle. And lastly, I have a reflex. And again, I can see, oh, it went past that 180, but it's not a full circle yet. So I am looking at that last one being a reflex angle. Okay. So, now that we know how to name angles and we know how to identify angles, let's take a look at this next example. This next example has this diagram, and this diagram kind of looks a little bit complex, but it's not too bad. Now, notice that as I've got here, I've got a bunch of different lines kind of branching off. The vertex, that middle point, is named A. But if I'm naming a single angle, in this case, I am definitely not just saying angle A, because which one am I talking about? You don't know. Am I talking about this angle A? Am I talking about this angle A? Gosh, I have no clue. So if I'm ever talking about a specific angle in this type of diagram, I'm always going to make sure I'm referring to it by using 3 separate points. Now I'm looking at this and I see a whole bunch of different kind of curved markings that help me identify the angle that I'm talking about. And there are certain measurements associated with it. So I can see that this angle here, B to A to C, is 22 degrees because I can see that curved marking is there. So what we're doing in this question is we're going to name the angle that has the specified angle measurement. Well, the first one I actually did as an example here. So I'm going from B all the way to point A, all the way back to point C. So I can say 22 degrees is the measure of angle BAC. Or I can do that backwards, angle CAB. What matters most is the vertex is in the middle. All right. I'd like you to pause the video. I'd like you to try the remaining ones as much as you can, and then we'll look at the rest together. Okay, welcome back. So 45 degrees, I see this 45 degrees is indicated with this yellow marking. It couldn't be this blue marking because the 52 is the one that's kind of closest to it. So I'm taking a look at this yellow marking, and I'm extending my lines here. And I'm picking a direction to travel. I'm going to go from F all the way to A, all the way to E, or I can go backwards. But I have F, A, E, or I can say angle E, A, F. Both totally acceptable. All right, moving on. I'm looking for that 52. That's this blue marking here, which means I'm going from G to A, to E. So I have angle G, A, E. Or again, I could have gone backwards and said angle EAG, making sure my vertex A is always in the center. 180. 180 is right next to this green curved marking here. Also, even if that marking wasn't there, I can see that this right here is a straight line. It connects B all the way to F, and if I used a ruler, I wouldn't have to shift my ruler anyway. It makes one straight, unbent line. So, if I were to go and name this, I go B to A to F, or FAB. Both work. Angle BAF or angle FAB. 68 degrees, I can see that's denoted with this orangey line here, or curve here, I should say. I'm getting CAD, angle CAD, or angle DAC. Both totally accurate, both more than welcome. 90 degrees. Now I'm looking and going, hey, I don't have a 90-degree number anywhere on my diagram, but I can see this small square marking, right? And we talked about right angles or 90-degree angles are indicated with that small square marking. So I can go from H all the way to A to B, H, A, B, or I can go backwards to B, A, H. Okay, 79 degrees. I've got this navy colored marking, so I have HAG as my angle, or angle GAH. Unless I've got 131. Well, this one, I don't actually have a 131 somewhere labeled in here, and there's no symbol that indicates a 131, which means I might actually have to add two side-by-side angles together to get that number, because I don't see it already labeled for me. So maybe I have to pick something or find something that will get me a total of 131. So I might go around and check. So if I'm taking a look, what if I went from this line all the way here? Well, that would be the sum of the 22 and the 68. Hey, that's technically 90 degrees, but that's not what I'm looking for. So that doesn't work. So I'm trying to find some things that add to 131. What if I talked about the 90 and the 22 all combined in one big angle? Nope, 90 and 22 don't add to 131. What if I went 79 and the 52? Okay, well, 9 and 2 do make a number that end in 1. And I think we found it. So if I'm taking a look at this angle here, I'm starting at H, touching A in the middle, and then going to E at the end. I know the angle measures, well, this part's 79, and this part's 52, so all together will give me that 131 degrees I'm looking for. So that would be angle HAE, or again, I can go backwards, angle EAH. Something I want to point out, remember that in every single one of these angles in this diagram, my vertex was A, which means the middle letter of all of my angles is an A, no matter which way I name it, because my vertex always goes in the middle of my 3 naming system. Okay, so we can name angles. We can identify types of angles. The last thing I want to talk about is relationships between angles. Now, there are 4 key angle relationships that we're going to talk about in this course right now. The first one is called complementary angles. Complementary angles are 2 or more angles that add together that sum to 90 degrees. So here I have an example of angle A, B, C, and angle C, B, D. And if I'm looking, this one here is 40 degrees, and this one here is 50 degrees. But together, side by side, they add up to 90. There's two things I want to point out in this diagram, other than I have my two complementary angles. Thing number one, look at my number of tick marks. These tick marks are different. Angle ABC, the one that I've kind of outlined in purple, I used one tick mark to indicate it. And angle CBD, I used two tick marks to indicate it. We often indicate things a little bit differently if they're not the same. So because they don't have the same measure, one way I can do that is I can use more than one tick or one curve kind of marking between them. The other thing I could do is if I had highlighters or something like that, I can do them in different colors to really show that they are different than each other. But the key thing is that when I add them together, 50 degrees and 90 degrees, 50 degrees and 40 degrees, I get a total of 90. So angle ABD gives me a 90-degree angle. And I can kind of see that in the corner. I had this little square marking as well. So angle ABD and angle CBD are complementary. Okay, the next angle property, we have supplementary angles. Supplementary angles add to 180. So together they form a straight angle or one straight line. So here I have two angles. I have A to O to B. Not really great tracing here. Try that again. A, O to B. Not that great, but better. And I have B to O to C. And those two angles, I didn't use different curve markings, but because I've color-coded them differently, it's okay. But I am going to add a second curve marking here to this guy, just to show that they're different angles in case I only had a pencil in front of me. But these two together form a straight line. If I add 65 and I add 115 degrees, I will get a total of 180. So angle AOB and angle BOC are supplementary. All right, the next one is called vertically opposite angles. Now, vertically opposite angles are formed when I have two straight lines that intersect. Okay, so here I have two straight lines. If I drew a ruler or used a ruler and drew straight all the way across, no bends, no bumps, no nothing, and then did another line, no bends, no bumps, no nothing, all the way across, these two lines intersected. And when they intersect, they form four separate angles. So I have this angle here, I have this angle here, I have this angle here, and I have this angle here. Now, when I have two lines that are straight that intersect, I create these four angles. But the fun thing is the two angles that are opposite each other across the vertex. So my vertex is that corner in the middle. Opposite is kind of like the word across. Okay? These two angles will always have the exact same measure. They will be the same size as each other. Or we can say they are congruent. Congruent is a word meaning that they are the same shape and the same size. Now, the fun thing about vertically opposite angles is it doesn't just create one pair that are the same shape and size. It creates two pairs that are the same shape and the same size. So when I take a look at this, I have two pairs of vertically opposite angles. Angle AOC and angle DOB are vertically opposite. But at the same time, angle AOD and angle forgot my angle symbol, angle COB are also vertically opposite. which means my measures of those angles are going to be equal. Okay, the last angle property for today. We have angles in a triangle. So if I have any triangle, doesn't matter what it looks like, a right triangle, a scalene triangle, any triangle at all, isosceles, equilateral, etc. All of the inside angles will always sum or add to 180. So here I have 3 angles. They're all different. I can see that because they've used 3 different colors to indicate that. If I can't see the colors on my page, I can go and put 3 different types of curved markings on them. So here I've put 2 on angle L, 3 on angle N, and just left the 1 on angle M. Here I have 3 separate angles, but also if I added those numbers up, 82 plus 56 plus 42, I should end up with an answer of 180. 2 plus 6 plus 2, 10. 8 plus 1 plus 5 plus 4, that's going to give me 18. So total, they add to 180 degrees. This is true for every single type of triangle you ever experience ever in your life. So very exciting. Let's talk about a little bit of notation here, just to make sure we're on the same page. So we have the word equal that we've seen before and used before, and we know what an equal symbol looks like. But we're also going to introduce something called congruent. Now, congruent is a word we use when we talk specifically about shapes, angles, and pictures. Equal is a symbol we use when we're talking specifically about numbers or angle measurements or anything that has numbers involved with it. So when I take a look at this, congruent and equal mean very similar things, but have kind of different niche uses. So congruent is like an equal sign with a single squiggle on top. I'm going to use that when I'm talking about angles. So say, for example, I was talking about vertically opposite angles. So these guys are vertically opposite. I can write the statement, angle AOC is congruent to angle DOB because they are vertically opposite. Notice in the statement I just wrote down, I did not use numbers. I just used the angle symbols, or if I was talking about shapes, I could use shape symbols. If I was talking about angle measurements for those exact same angles, I could say 145 degrees is equal to 145 degrees. Because I'm using those numbers, same vertically opposite angles. Actually, I was talking about AOD and COB. That's on me. But I can say that these two numbers are equal to each other. So congruent is used when I'm talking about symbols and notation for angles. Equal is used when I have numbers associated with them. Okay, we are so close to done. We are going to go ahead and try and find the value of the indicated angle. So when I take a look at this, I don't have any points in here, but I'm trying to find the value of little b. I don't know what little b is. I know the b is in this little nook and cranny here. Just want to figure out what b is. When I figure out what b is, I also want to indicate how I figured that out. So I want to list or state the angle relationship. So my options are complementary, supplementary, vertically opposite, or angles in a triangle. So I'd like you to take a moment, try these examples on your own, see if you can figure them out, and then we'll go through it together. Okay, welcome back. So when I take a look at this, the first thing that stood out to me in this diagram was this little square here. And that little square, remember, is a symbol of a 90-degree angle. But I don't have the whole angle measurement being 90 degrees. I only have b being a part of that. Right, angle b, or that value of b, is found in between here. And 37 is found in between here. But together, they make a 90-degree angle, meaning that they are complementary. Complementary. Which means the 37 degrees And B, whatever B is, will add to give me 90 degrees. And luckily I have a lot of algebra skills, so I'm going to subtract 37 from both sides to get that unknown B value alone. And when I do that, I go 90 minus 37, and that gives me 53 degrees. So the value of B must be 53 degrees. Okay, looking at the next one, I do not have a 90-degree marking, so I'm kind of ruling out complementary. I do have a triangle, but I'm not talking about all of the values in my triangle here, so it's likely not that one. But when I'm taking a look, I've got 81, and I've got B. And together, I notice they make one straight line, right? That 81 and the B together make a straight line. And that means that they are supplementary. Those two angles add to give me 180 degrees. So 81 degrees plus whatever B is equal to 180 degrees. And again, I could use my solving equation skill. To get B alone, I'm going to subtract 81 degrees from both sides. And I find out that B is 99 degrees. Okay, last but not least, I'm talking about angle B here. And I'm talking about the 41 degrees there. Now, I know that they are not complementary. There's no indication that there's a 90-degree angle anywhere. They are also not supplementary because them together do not total or add to make that straight line, right? Take a look. Here I've got these two. I do notice, however, that they are formed when two lines intersect. And that vertex in the middle, they are opposite from each other across that vertex, meaning that they are vertically opposite. And I know that vertically opposite angles are equal to each other, or equal in number, or congruent, meaning they're the same shape and size. So with that being said, I can say B will be equal to whatever 41 degrees is. Well, that's technically already solved. So yay, we've done it. Now we can get a little bit more complex, but we won't go too much more complex than this, but we're going to do the exact same thing. It looks a little bit scarier because there's some variables in there, but I promise you it's not too much different. Okay, so I'm looking at two angles. I've got this angle here, the 4n plus 22, and I've got this angle here, the 8n minus 10. And I want to know what relationship exists between them. Well, I can see that together they form a straight line, which means those are going to add to 180, which means I have supplementary angles. And I know that supplementary angles add to 180 degrees. So just as before, I wrote what my two supplementary angles were. I added them together and wrote equals 180. Do the same thing here. 4n plus 22 degrees plus my other angle, 8n minus 10 degrees, is going to add to give me 180 degrees. Now remember, last unit we talked about solving equations, and before we, undid anything, we started by simplifying both sides, looking for like terms. So I'm going to do the same thing here. On my left-hand side, I have two different sets of like terms, so I'm going to combine them. I've got 4n, I've got 8n, so I've got 12n together. And I have 22 degrees minus 10 degrees, which will give me positive 12 degrees. And I know those things still equal to 180 degrees. No biggie. Now, when I go ahead and keep on rolling with this, I can now do my reverse operations to get n alone. So I'm going to go ahead and do that. I'm going to subtract 12 degrees from both sides, and I get 12n is equal to 168 degrees. Now again, to get n alone, I am going to divide both sides by 12 to make that coefficient of n a 1. And I'm going to do that to both sides, and I end up with n is equal to 14 degrees. Now this is very exciting. I know what n is because I'm solving for that variable. But if I wanted to verify or double check, something I can do is I can plug 14 back in for n in both of these things and see if I get two angles that end up adding to 180. Now I should, if I've done the math correctly, but just know we're going through this, and that's one way I can double check. Okay, last but not least, I have 8x, which is this angle here, and I've got 2x plus 72, and I can see that they meet at the vertex n, and they are opposite from each other across the vertex, meaning I have two angles that are vertically opposite. And I know that vertically opposite angles are congruent, which means the angle measures of those two angles will be equal. So I can set 8x equal to the other angle, which is 2x plus 72. Right? If those two angles are equal in size, I can set up an equation to make them equal. As I'm going through, I've got my algebra skills. I can go ahead and say, both sides are simplified, but my next step is to move all of my variables to one side. So I'm going to move my 2x's using zero pairs to the left. So I get 6x is equal to, I forgot the degree sign on that 72. Good catch. Is equal to 72 degrees. And I'm going to divide now both sides by 6 so I could get x alone. I'm turning that coefficient into a 1 on the x. And I get x is equal to 12 degrees. Okay. Whew. So there's quite a bit that we've learned in this lesson. We learned how to appropriately name angles. We've learned 4 different relationships that angles have, and we use those angle relationships to go even one step further and solve for an unknown. Now there's some practice that follows, so please work on that practice. Make sure you get it all done. But otherwise, that's it for today. I hope you have a really wonderful day. Bye.